Hello everyone. Today we're going to be going through the explainer video for work and energy. So I'm going to screen share here quickly. Okay. So, all right. So the problem I was assigned was problem 2 from expert TA, and it says that a shopper pushes a grocery cart for a distance of 21.5 meters at a constant speed on level ground against a 37.5 Newton frictional force, and he pushes in a direction that is 26.5 degrees below the horizontal. And then for part A, asks what is the work done on the cart by friction in joules. So before we even start working on the problem, as per usual, we're going to at least draw a picture and a free body diagram just to get a sense of the forces and what this system basically looks like. So I have my drawing here and did my best to draw well. I'm not the best draw, like I'm not the best artist, I guess, but did the best I could. So and then over here, we got our free body diagram. So gravitational force, normal force, the negative frictional force, as well as the angle from the shopper pushing. And so basically the strategy that I used throughout this whole problem was to basically either use the work energy theorem, which is how we start most of these problems, but it doesn't really apply too much here, at least like equation wise. So we're going to be using mostly just the work formulas. So to solve part A here, we just need to define the frictional force of the work, basically, or we need to find the work, which is basically just negative force of friction times distance. So I just did this calculation right here, and then you get negative 806.25 joules. And then for part B, it asks, what is the work done on the cart by the gravitational force in joules? And the problem for this part, or pitfall potential mistake you can make, is that you might say, oh, there is a gravitational force on the system, so it might be doing work. But even though there's a gravitational force, there's no actual acceleration in the y direction. So there's no work done by gravity on the system. So you can't always assume that a force will do work on a system. There must be an acceleration for that to happen. So in this case, the answer is 0. And so for part C, what is the work done on the cart by the shopper in joules? So the cart is moving at a constant velocity, which means that the work done on the cart by friction is the same as the work done on the cart by the shopper. So basically, in other words, you can go back up to this one and see that the frictional force, since it's a constant velocity, the frictional force will be equal to the force that the shopper is done by the shopper. And so it has here, it's the same answer, it's just 806.25 joules. And then for part B, or part D, excuse me, it asks to find the magnitude of the force in newtons that the shopper exerts on the cart. So again, you're going to be using the definition of work equation, except this time you're going to rearrange it to solve for the force done by the shopper. And so if you do the calculation right here, you just get 41.9 newtons, pretty simple. And then for the last part, it asks for part E, what is the total work done on the cart in joules? And so another thing that messed me up on the homework was that I made this problem more complicated than it is, because it sounds complicated, but it's really not, because the car is moving at a constant velocity, like we said earlier. So the sum of the forces must be equal to 0. And so therefore the total work done on the cart is 0, because that constant velocity makes it so the total work done on the cart is equal to 0. So most of the time you want to, instead of just jumping into an equation and just trying to calculate it right away, you can just use mostly your intuition to see if you can get to the answer without having to do any calculation. Because if you just stop and think, if you use what you know, you can see that the total work will equal 0 based on the conditions of the problem. So yeah, I'm gonna stop sharing here. Alrighty, so that's how you work through that problem, and thank you all for watching.